All right, we're continuing with 11.1, where we are figuring out probabilities. And remember, we're at a stage where we're utilizing Chapter 10 skills. So we want to ask ourselves after we read these problems, does order matter? And are repeats allowed? So 4 married couples arrange themselves in 8 consecutive seats in a row. Find the probability that the men will sit in 4 adjacent seats. This keyword arrange tells us everything we need to know. It means order matters and repetition is not allowed. So remember, if we want to build probability, we are looking for the likelihood this event will occur. So we're going to create a fraction. The denominator of our fraction will be the answer to just the general task. The general task is arranging 8 people in 8 seats. So we could say that's done by 8 factorial. Remember, that would be 8, 7, 6, 5, 4, 3, 2, 1. Which makes sense. 8 people could sit down first, then 7 people could sit down second, then 6 people could sit down third, so on and so forth. Now the top I'm going to split into the 8 individual seats. And one way that the men could be in 4 adjacent seats is if they all sit down first. So there are 4 men, followed by 3 men, followed by 2, followed by 1. Now there are 4 women, followed by 3 women, followed by 2 women, followed by 1. But this doesn't quite get us our answer yet because it doesn't say all the men have to sit first. It just says they have to be in adjacent seats, which means side by side. So man, 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 woman, 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 woman is one example of this. But if you shift one woman forward, the men can all still stay together. If you shift 2 women forward, the men can still all stay together. If you have 3 women first, the men can still all stay together. And finally, if all the women are first and all the men are last, they are still together. This is 5 different ways. Each of these ways has this as a way of doing it. So this value has to be multiplied by 5. That is going to be, when you work that through with your calculator, 1/14 or 0.07 as our answer. Let's take a look at a group, a class size group. So let's say Anne, Bethany, Claire, and Denise are 4 of the 25 members of the class. And 4 class members will be chosen randomly to do a math problem on the board. What is the probability that Anne, Bethany, Claire, and Denise are selected in that order? Well, let's draw out a fraction bar because we're doing probability. And let's think about the general task. The general task is, of 25 members of the class, take 4. Well, does order matter? It sure does, because they are being assigned a certain position to present at the board. They either present first, or they present second, or third, or fourth. Now, repetition isn't allowed because once a class member goes, they won't go again. So the bottom is 25 people, arrange 4 of them. Now the top is Anne, Bethany, Claire, and Denise must be selected in that exact order. Well, there's only one way to do that. They have to go exactly as stated. So this is 1 over 303,600. You could certainly leave it as that answer. It's already in reduced form. Now what happens? How does our answer change if Anne, Bethany, Claire, and Denise are selected in any order? Well, still order, but now any order means Anne could go first, she could go second, she could go third, or she could go fourth. So the bottom doesn't change. The denominator is still representing the general task. Order 4 people out of 25 to present problems at the board. Now the top is P4. It's 4P4. The reason why this time is because 4 people are arranging themselves in any order. Remember, so Anne could be in the first position or she could be in the second, so there's all kinds of ways. So now this is 24 over 300, 3,600. Or we can get 0.00008. Sometimes the decimal's easier than reducing the fraction. All right, so a student has the option of selecting 3 books to read for a humanities course. The suggested book list consists of 10 biographies and 5 current event books. The student decides to select the 3 books at random. Find the probability that all 3 books will be current event books. All right, so let's look for some clue words to help us decide about order and repetition. So the 3 books are chosen at random, which means order does not matter. And he is selecting 3 books, so that means they're all unique, so repetition is not allowed. So we're going to build out our fraction. The bottom is just the general task. What is the student doing? He's selecting 3 books from how many? 15. So 15C3. Now the top is we want all 3 books to be current event books. So it's still C3 because order doesn't matter and we cannot repeat. But we want to drill down this 15 to only current event books. So we're going to look at the 5 in our list. And we're going to get 2 over 91. All right, what is the probability of getting a 5-card poker hand all the same suit? All right, so remember, poker. Every time we make a poker hand, we know to use a combination because order doesn't matter how you hold them in your hand. And there are 52 unique cards. You can't have a repeat. All right, so the bottom is 52 cards because that's how many are in a deck. C5 because we need 5 in our hand. Now the top, we want all the same suit. So what might make this problem easier is to pick a particular suit. So let's think about diamonds. Well, how many diamonds are there? There are 13 diamonds. So what if the question asked instead of all the same suit, what if it said 5 poker, what if it said a 5-card poker hand all diamonds? Well, we would say 13. C5. We would say there are 13 diamonds. We need 5 of them. Well, what would we multiply this by to incorporate all of the suits in a deck? Well, remember, there are spades, clubs, and hearts. So how many suits are there? There are 4. So we're going to multiply this by 4. Our answer then will be 5,148 over 2,598,960, and we will get 0.002. All right, 11. A box contains 24 transistors. 4 of them are defective. If 3 transistors are selected at random, find the probability that exactly 2 are defective. All right, let's ask ourselves some questions. What's the task? What are we doing? Well, in general, we're picking 3 transistors from 24. And we're doing it at random. So order doesn't matter. And repeats aren't allowed. All right, so the bottom of our fraction for our probability answer would be 24 transistors. In any order without repeats, I need 3. Now the top, we want to have exactly 3 of our transistors. We want out of exactly 3 of our transistors, we want 2 of them to be defective. Well, this has to utilize the fundamental counting principle. We need to pull into play a 2-part job because we need to control that 2 are defective and 1 is good. So we need to split this into a 2-part task to control how many are defective and how many are good. Well, let's do the defective ones. If I need 2 defective ones, how many transistors are defective? Well, we're told 4. So we're going to say 4C2 times how many are good? Well, if there are 24 total transistors and 4 are defective, then the rest are good, or 20. So any of those 20 would work for the good one. So we could just write times 20. If you were thinking write 20C1, that'd be okay too. So this is fundamental counting principle. In the top, you'll get this with your calculator and multiply by 20, and you'll end up with 120 over 2024, which you could say is 0.059. Now again, remember, probability answers should always fit somewhere between 0 and 1. If you'd rather reduce your fraction, you can do so. A decimal is perfectly fine. All right, last one here in 11.1. So we have digits 1, 3, 6, 7, and 8. And we are randomly arranging them to form a 5-digit number. Find the probability of each of the following events. The strongest key word in this problem is to arrange. Arrange means all 5 of these will be used in some very important order, only once each being used. All right, so how about the number is even? All right, so probability, got to draw a fraction bar, got to figure out the top and the bottom. The bottom is the general task. Well, what's the general task? We're making a 5-digit number from these 5 numbers. All right, so I could say I am arranging 5 numbers, so 5 factorial. Now the top is, I'm going to use the fundamental counting principle to do the top. So I'm going to do 5 dashes, a place for each of the 5 digits, and I'm going to think about the back end first. The last number is what controls if a number's even or odd. So if I want an even number, I have 6 and 8 that could be last. Now once one of those numbers is used, there are 4 remaining numbers that we could go back and start with. So this is 4 times 3 times 2 times 1 times 2. So with our calculator, we get 48 over 120, or we get 2/5. All right, last one. The first and last digits of the number are both even. Well, what doesn't change? The denominator. They didn't change the task. We're still building a 5-digit number using these 5 numbers and arranging them. So this is still 5 factorial. The top could still be thought of as 5-part task, a spot for each of the 5 digits we're using. Well, what'd they say now? The first and last digits are even, so 2 numbers could go at the end. Now only 1 number could go in the beginning because remember we're arranging, so each number can only be used once. Now we have 3 numbers left to use 3, 2, 1. So we get 12 over 120, or 1/10.